How would we know? And what could we actually do about it? In this video, we'll play out a fictional asteroid headed for Earth with some help from my friend and former NASA engineer, Mark Rober, and rare access into a remote facility where they discover new asteroids.
Oh, look at that. What do you got?
Is that real? To show you all of the amazing, real science and tech that we would use to defend our planet if an asteroid is about to hit Earth. So in order to make sure that you know what's real versus what's our fictional asteroid crisis, I asked Mark Rober to voice the fiction sections, and it turned out so fun.
Let's go. It's 3 a.m. on June 1st, 2034. Scientists inside Catalina Sky Survey in Arizona have been awake all night, hunting for asteroids. Their telescope is taking time-lapse pictures of the night sky in a grid like this. Each spot of the sky is photographed 4 times moments apart, and that lets them find moving asteroids against the stable stars in the background. Oh boy, I'm already nervous, Cleo.
You got this.
It's slow work, and they're tired. But new photos just came in. Wait, that can't be right. That looks like a new fast-moving point of light against the sky. Is that what I think it is? Is that what I think it is?
Yes. Right now, we're at the real Catalina Sky Survey because they've invited us to spend the night with them while they hunt for real asteroids. Since the 1990s, this place and places like it around the world have scanned the sky while we're all asleep, hunting for dangerous objects that might hit us. Together, these ground-based observatories have detected the majority of the near-Earth asteroids that we know about, over 39,000 so far. We don't think about it very often, but our planet is in a constant, high-stakes dodgeball game, and we can't dodge. So our only hope is to identify asteroids long enough in advance to do something about it. We're the only species to ever have a hope of doing that. For anyone else, when an asteroid comes. The asteroid that killed the dinosaurs was wider than Mount Everest is tall. But what I didn't realize is that asteroid, it wasn't that big. At least not compared to other asteroids that have actually hit Earth before. Imagine hunks of rock or metal, all different shapes, up to about the size of a 10-story building. There are likely millions of these flying around closer to us than Mars, and they hit us all the time. But our atmosphere protects us. These small asteroids almost always burn up long before they reach us on the ground. But asteroids get bigger. From the size of a building to about 2 city blocks, there are likely hundreds of thousands of asteroids this size near us. On June 30th, 1908, a rock 50 meters across grazed our atmosphere over Siberia. It never even hit the ground, but just the shockwave flattened 80 million trees. And if it had hit, well, an asteroid impact is worse than you might think. Most people imagine an asteroid hitting Earth like a bullet hitting a wall. But an asteroid is not like that. An asteroid is almost always going so fast that when it hits, much of it immediately turns from a solid into a superheated gas that explodes outward. And the energy of that explosion is insane. A 50-meter asteroid would release the energy equivalent of around 500 nuclear bombs. That's why this size is called a city killer. But they get bigger. Anything this size would wipe out a whole country. And anything bigger than that, all life on Earth would change forever. That rock that hit the dinosaurs caused mega tsunamis, a thermal pulse of heat and fire, dust and ash that blocked out the sun for a decade or more. But that's nowhere close to the largest rock that has ever hit Earth. 1.8 billion years ago, a rock nearly 15 kilometers wide slammed into what's now Canada. And 170 million years before that, the largest asteroid that we have evidence of ever hitting Earth, 20 kilometers wide, struck what is now South Africa. If you'd been on the ground and looked up, an asteroid that size would look something like this. And even bigger than that, it's theorized that an object the size of Mars hit Earth about 4.5 billion years ago, and that's how our moon was formed. But something I found interesting when talking to experts about this is that not all asteroids hit our planet the same. An asteroid made of ice and rocky debris might hit our atmosphere and break apart, burning up on entry, while a dense metal asteroid of the same size could pierce straight through and maybe do more serious damage. But the good news is that based on our rate of discovery and computer models of our early solar system, astronomers say that we've already found about 95 to 98% of the really big asteroids, the ones about a kilometer wide or more. As of today, there are exactly 877 of them, and scientists track them very closely. And luckily, none of them are on track to hit us. But those city and country killers. For the country killers, they think we've only found 42 to 47% of them. And for the city killers, the number is much, much less. And we're much less certain about that percentage. That is the biggest hole in Earth's defenses right now. And that is what people all around the world are staying up all night trying to fix. And I'm about to become one of them. So we just opened the doors to the telescope. We're now all set to start the observation run. We just have to wait until it gets darker and then we can start hunting asteroids. They told us that based on the weather, we might find a brand new asteroid tonight. So I have my fingers crossed. As we waited for the sun to go down, I found out something that made me very excited. If you find a new asteroid, you get to put your name on it. And I really want to do that. But it turns out finding a new asteroid is way harder than I thought.
So this is a map of the night sky that shows the coverage from this telescope over about the last 2 weeks. We'll cover the entire night sky about twice a month.
The telescope takes pictures of 12 spots of sky at a time, each 4 times in a cycle. So the 4 images of each spot are brief moments apart. And then an automated system analyzes each set and shows the observer just the maybe options. The vast majority of those are still no's.
So you see the N key is a little worn down on the keyboard. That's the key we hit the most.
Okay, here I go. Not real.
Okay.
Not real. Nope. 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 Definitely nope. This went on for hours. David and I took turns, and I really wanted to stay awake. So I did a ton of push-ups, and I drank a ton of coffee. And when I was at the observatory, I drank whatever coffee they had. But when I'm at home and I can choose, this is the really good stuff. It's from Cometeer, and the reason why I love it so much is because it's delicious. I genuinely drink their coffee all the time, and because it's genuinely cool technology. Even if you buy great coffee beans, it's hard to make a great coffee at home, and that's why I've been using Cometeer. This is the first coffee that's brewed to perfection and then flash frozen at peak freshness, which makes a big difference when it comes to taste. So Cometeer goes out and they find the best beans from roasters around the world, like Intelligentsia and Onyx, and then they brew the coffee at 10 times the strength of a normal cup, and they flash freeze it into a capsule like this. Then I can just take that capsule, and without a machine, you can just pop it out like this using the eject button. And then you can make it hot or iced or an iced latte. Boom, the perfect cup every single time, and it took less than a minute. Plus, it's got twice the flavor and caffeine of a regular cup. Perfection. Right now, this one is my favorite flavor, but you should try it out and comment yours. So if you're sitting here and you're thinking, man, I would love a good cup of coffee, try Cometeer. I think you'll like it. And if you haven't tried Cometeer, you can get $20 off your Discovery box, featuring 8 unique coffees curated by World Barista champ James Hoffman by visiting cometeer.com/Clio or visiting the link in my description. But back at the observatory, it was hard to stay awake. And at a certain point, I found myself wondering, why is it that you need to be physically here as opposed to you have this amazing software, it detects these images, you come in tomorrow morning and you say, that's real, that's not real, that's real, that's not real.
The turnaround time on the data is critical.
Because those 4 images, they only show a tiny little piece of an asteroid's path. So if you waited until the morning, you'd probably lose it.
If you don't continue to track that object and publish it immediately, it literally can get lost.
So when you find something, you immediately send it to what's called the Minor Planet Center to check if someone else has already found it. And if it's a new object, other telescopes around the world lock onto its position to help build out its orbital path for the foreseeable future. This is all public. Anybody with a telescope can help. And we'd all need to help if anyone found anything big enough.
The observers are still staring at that moving speck of light. Something that bright is likely an object we know about already. So they report it to the Minor Planet Center. And normally, they'd be hoping to make a new discovery. But today, they're just hoping their suspicion is wrong. And as soon as the report comes back, the whole team goes silent. No one's ever seen this thing before. It's a new asteroid, and it's big. Cleo, you're making me narrate the end of our species. Astronomers around the world spring into action. They need to know how big and what it's made of. And, most importantly, will it hit us? How will they know what it's made of from their telescopes?
You're about to find out.